Alright, so the goal of yesterday was to divide polynomials using long division. Our goal today is to use a secondary method, but the problem with today's method is that it only works sometimes, where, as we discussed yesterday, long division works all the time. So what I want to do to start is kind of do a warm-up with a long division example. It's, like I said, it's not on your notes. It's just me kind of giving you an extra example to work through and look at how long division works. So we talked about the fact that yesterday when you used long division, you had two cases. You had the case where a binomial divided perfectly in and created a factor. And then we had the case where we had remainders. So, for example, if we had 6x squared plus 7x minus 20, and we said that we want to divide that by 2x plus 5, oftentimes the reason we are dividing by a binomial is to see if that binomial is in fact a factor. So what we would do is set up our long division. So the numerator becomes the dividend. The denominator is the divisor. And then we work through and kind of do long division the same way we used to do with numbers, but now with variables. So we look at the term here and we say, okay, what do I need to multiply 2x by to get 6x squared? So I need to multiply 2x by 3x, because 3x times 2x is 6x squared. That 3x also multiplies to the 5, so you get 15x. After you do the first round of multiplying, now we subtract or change the signs so that the first terms zero out. So 6x squared minus 6x squared is 0. You should always get a 0 in the first column of terms. If you don't, then you need to go back and maybe change your signs, or maybe you forgot to subtract. 7x and 15x get added together so that we have negative 8x. Bring down the negative 20. So I need to now multiply 2x by something to get to negative 8x. So remember, the first time I multiply through, I want to match the signs. So I'm going to multiply by negative 4. So negative 4 times 2 is negative 8x. Negative 4 times 5 is negative 20. Once I've multiplied through, now I subtract, so that means I change the signs. And negative 8x plus 8x is 0. That's what I need to have happen. Now I also get 0 on the second part of this term. So if I get 0 at the beginning and 0 at the end, then I am super duper happy, because what that means is 2x plus 5 is in fact a factor of 6x squared plus 7x minus 20, and I have no remainder. And the answer is equal to 3x minus 4. Any questions on long division? Anything that you're still unclear about? Does the warm-up example kind of help those of you if you were still maybe struggling yesterday? Or weren't here yesterday? Yes?
So like if you did have a remainder, you would have like what you have on top and add it together.
Yes.
And then you add and put the remainder 2x plus 9 in the denominator if there was a remainder.
Yeah, so like if instead of a 0, like let's say I got, maybe it was negative 40 instead of 0, what you do is you take your remainder, you would write it at the end, and then also it gets written on top of the divisor.
I just wanted to make sure because I was like mixing it up a little bit honestly.
No, that's a great question. And again, I know this is something, it's been a long time since you looked at long division. And I want to make sure we're okay. And if we have questions, I want to be able to answer them before we look at synthetic. That's why I kind of added a warm-up problem that wasn't in your notes, just to make sure we're okay. So did everybody kind of understand Lexi's question? What do you do with the remainder and how do you rewrite it? So you take the remainder and it gets written over the divisor at the end of the long division. Do we want to do another long division example? Or are we okay? Does anybody want to see another long division example? Just raise your hand and I will gladly do one. All right. Got at least one hand raised, so we're doing another one. All right, let me try to find one so that I'm going to get a remainder so you can see it as like an example. All right, I believe this should give us a remainder. All right, so if the first term is x cubed and our divisor is x, we have to say, what do I multiply x by to get x cubed? That means I need x squared. X squared times x is x cubed. X squared times negative 7 is negative 7x squared. Once you've multiplied that through, you change your signs. The first term should zero out. Negative 12 and positive 7 becomes negative 5x squared. And you bring down the next term, which is a positive 38x. Whenever we are looking at this, once again, you're only looking at the first term here and the first term there. So I say, what do I have to multiply x by to get negative 5x squared? So I need to multiply by negative 5 and an x. So negative 5x times x gives negative 5x squared. So when you're picking what you multiply by, the first time you pick it, those terms should match. Then, when you add or subtract them, depending on what sign it was, they should zero out. Negative times a negative is a positive 35x. But now I change both of my signs, so the first term zero out, and 38 minus 35 is 3x. We're going to bring down that negative 17. And once again, you look at the first term here and the first term here and say, okay, what do I need to multiply 3x or x by to get 3x? The answer is a positive 3. So you take the positive 3, you distribute it to both of these terms. And then once again, you change the sign. So a 3x minus 3x is 0. But this time, negative 17 and positive 21 is a 4. That 4 is my remainder. That tells me that x minus 7 is not a factor of the original. So at the end, I write plus 4 over x minus 7. Okay, so I feel much better. I feel like I'm seeing a lot of head nods. I feel like I'm seeing some clarity. That's why sometimes I really like the fact that, like, for homework assignments, you have sort of an extra day on some of them so that we can go over harder questions, talk about topics, and do some review. I promise that if you didn't like long division, you're probably going to like synthetic division, because synthetic division is sort of more of a formula that works. But, like I said, long division works for any example. Synthetic division has limitations. So, as part of the bell ringer, I wanted to talk about just the ordering of terms, going back and discussing some of that terminology that we talked about in 6.1. So it said, in what order should we arrange the terms when you divide a polynomial? The terms should be listed in order from largest to smallest. How do you determine where to place the first term in the quotient? The first term of the dividend is equal to the quotient of the first term times the divisor. So again, think about the dividend is in the den. That goes what's under the divising bars. The divisor is what you are dividing by. It is the denominator. It's what goes on the outside. And then the last thing is, how do you know when you finish dividing a polynomial? So if you look back at the examples we just had, you're either going to get a 0, 0, or you're going to get a single number. So in that last one, we got the number 4. That's considered a single number. And the example before that, you got 0, 0. So how do you know you're finished? You know you're finished when you have a single number or a double 0. So again, yesterday our goal or topic was long division. Today we're going to learn a concept called synthetic division. I have a feeling this is the first time you've seen this topic or concept. So we're going to walk through the example in steps. Like I said numerous times, there are 2 rules that must apply when you're using synthetic division. So the first 2 things that have to happen is the coefficients must exist. We saw yesterday if a coefficient for a variable doesn't exist, we can add it in. So you can add in a 0 times any variable, and that will act as a placeholder for a missing variable. So we're going to use a 0 times a variable, and it acts as a placeholder. Number 2 is the most important rule for synthetic division. The divisor must have a leading coefficient of 1. The divisor must have a leading coefficient of 1. So what that means is that whatever you are dividing by, the value on the x has to be 1. So it doesn't matter if you are adding or subtracting a variable or a constant to it. It has to be divided by a 1x. So you could not do that first warm-up example we did, because that first warm-up example was 2x plus 5. Synthetic division would not work for a problem in which you divided by 2x plus 5. because the leading coefficient in that case was 2. So there are several steps we're going to follow when it comes to synthetic division. If you look at example number 1, the terms went x to the 4th, then x squared, x, and 6. So rule number 1 is you must have a spot for each variable. So we're going to put a 0 in with x cubed. So the numerator did not contain all powers of x. So we're going to include a 0x cubed to account for that problem. So step 1 is always to make sure that you have a spot for every variable and that the degrees of the variable descend. Step number 2, whatever our divisor is, we are going to take the opposite of the number. So if our divisor is x minus a is considered 3. That 3 is going to go in the box. So in the divisor it was x minus, the 3 is positive. So it goes back to h being the opposite of what it was. The divisor is always going to have the opposite power in synthetic. So if it's x minus 3, then the box number is positive 3. If it was x plus 3, then the box number would be negative 3. The next step is to write down the coefficients of every term. So the 5x to the 4th has a coefficient of 5. 0x cubed has a coefficient of 0. Negative 4x squared has a coefficient of negative 4. 1x has a coefficient of 1. And 6 has a coefficient of 6. So you take the opposite of the divisor and the leading coefficients of each term. That's why they have to be in descending order. Step 2 is to write the leading coefficients. Step 3 is to bring down the first coefficient exactly as it is. So your first step is to bring down the first coefficient. After you bring it down, it's almost like long division in reverse. You are going to take the number in the box, multiply it by the number you brought down, and fill it in under the next leading coefficient. So 3 times 5 is 15. And then here's what is really nice. Step 5, add the next two terms together. So the next thing we're going to do is add. So we add the columns and we multiply the diagonals. So you add the columns and you multiply the diagonals. So you're going to add 0 and 15. And then multiply 3 times 15. So 3 times 15 is 45. So that's going to fill in the next column. So you add, multiply, add, multiply. So 3 times 41 gets multiplied. And then you add. And then last but not least, you multiply. So we repeat that add, multiply step until we get to no more columns. These represent the coefficients of the divisor. So these would be like what was on top of the dividend in long division. So what we're going to do is, since this started as 5x to the 4th, You divide it by x, so that makes this 5x cubed plus 15x squared plus 41x plus 124 plus that last number is our remainder. It goes over the divisor. If that last number is 0, then there is no remainder. So we're going to look at several more examples. Again, I know this is the first time you're seeing it. It's kind of why I have each step and process listed. I promise once you kind of get through them, you're going to see that it's the opposite operations of long division. What? Okay. So in example number 1, we have t cubed minus 6t squared plus 1. So what you should notice is that from t squared, we go straight to 1. So we are missing t. So you would rewrite that as t cubed minus 6t squared plus 0t plus 1 divided by t plus 2. When you look at the divisor, the coefficient of t is 1. Therefore, synthetic division applies. You take the opposite of the a value. So if it's t plus 2, in your box, it's negative 2. Our next step is to write down the coefficients of the dividend. So the coefficients are 1, negative 6, that placeholder is 0, and positive 1. And then what we're going to do is follow the rule. So you bring down the first term exactly as it is. So that 1 comes straight down. You multiply negative 2 times 1. So negative 2 times 1 is negative 2. And then you add negative 6 and negative 2 together to get negative 8. Negative times a negative is a positive. 2 times 8 is 16. Add them straight down. Multiply. Negative 2 times 16 is negative 32. Add them straight down, and you get negative 31. If the original is t cubed, and you divide it by t, then you're taking a variable away. So t cubed over t would become t squared. So these coefficients now take 1 less power than the original. So this is 1t squared minus 8t plus 16 minus 31 over t plus 2. What I want to do is show you how this example compares to the long division that we previously did yesterday. So if you were setting this up for long division, you would have said, okay, t plus 2 goes on the outside. T cubed minus 6t squared plus, let me get myself a little more space. So you would have set it up exactly like that. And then you would have gone through a similar process. You would have said, what do I have to multiply t by to get t cubed? And you'd say t squared. That gave t cubed plus 2t. Then the rule is you take the opposites, so you subtract. You got 0. You get negative 8t. Where do I see a negative 8? So what do you have to multiply t by to get to negative 8t? You negative 8. T. So you have negative 8t times t, which is negative 8t squared. You brought down the 0t. So you have negative 8t squared times 2, which is negative 16t. Take the opposite signs. You get a 0. You have 16t that is now negative, plus 1 at the end. And then again, what do you have to multiply t by to get negative 16t? Or sorry, positive 16t. t times 16t. 16 times 2 is 32. Subtract them and you get negative 31, which is the same remainder and answer we had here. So you can see how the two methods get you to the same answer. They're just getting you there a different way. Personally, I think this way is easier because you can get jumbled in your steps in long division. But once again, there are certain problems that you have to do with long division because synthetic division does not apply. Okay. And then, do you have one more example on your handout? No? Would you like to do one more example of synthetic division? Okay, so let's look at a new example. So just kind of add this to the bottom of your page. Let's take so we have 3x cubed plus 4x squared minus 3x plus 7 divided by x plus 2. The leading coefficient of the divisor is a 1. Therefore, synthetic division applies. You take the opposite of the bottom. So if it's x plus 2, in our box for synthetic, we're going to put a negative 2. And then you're going to write down the coefficients of the numerator. So that's 3, 4, negative 3, and 7. Since these terms descend without a missing power, we don't have to put in a 0 placeholder. And then we're going to add and multiply. So you bring down the first term, multiply the first term by the number in our box. So negative 2 times 3 is negative 6. Add the columns, so you get negative 2. And negative 2 times negative 2 is positive 4. Add the columns, so you get 1. Multiply the diagonals, negative 2. Add the columns, and we get 5. These now represent the leading coefficients for a power 1 less than the original numerator. So it's 3x squared minus 2x plus 1 plus 5 over x plus 2. If the last number at the end was a 0, then you would have a perfect factor, and that would mean that the divisor was a factor of the numerator. Is it starting to kind of click into place now? This is definitely one of those problems you almost have to practice them kind of independently to get the hang of it. Because once you start to do it on your own and follow the steps, it starts to make more and more sense. So your homework is that next handout in that packet. Tomorrow, to sort of assist you with this idea, there is a Delta Math assignment that we're going to work on so that you can kind of walk through the steps on Delta Math. They have a couple where they have you fill in the blanks with the synthetic. You're doing some dragging and dropping and getting just some extra practice with synthetic and long division. When we come back to class on Thursday, we're going to look at classifying and we're going to look at end behavior of graphs. Yes?
So when it
No, ask.
like when it ends early, so like if it were to end at like X or something, you just stop it there.
Add a 0. Sure. I have this packet. So 30 and 31. So you want me to try? I'll do one with you if you want. So like if we did 28. So the first one you just did G cubed, right? Change your sign. So then you got negative 2g cubed, and you brought down the 3g squared. So when you multiply, g cubed times negative 4 is negative, but then you have to subtract it, so it becomes a positive. So it should be negative 6g cubed plus 4g cubed. And that's probably why your numbers weren't making sense. All right, let's look at number 30.
All right, well,
That's okay. Did you remember to put 0 placeholders in number 30? Okay.
but they're true. They're literally cheap.
Perfect. So the first one was 2z5.
Well, besides the long distance ones, because we didn't have 3 people on it.
And so then you had negative, positive. So you had positive 12z5. Bring down the positive 3z4. So up top, your next number was a positive 4z4. Yeah, me too.
I'm almost done. I just have a question. Do I need to ask? Can I just I know you have to add I don't know, like.
You have to add a 0 at the end.
So then I don't, so I just add 2a, I don't make that.
It has a divisor. It has a fraction.
Oh, it does have a fraction,
Yeah.
so that 2a.
I didn't realize.
Okay, thank you.
Okay, so I have 27c to the 4th. 24 plus 3 is 27. Okay.